In this video, we will look at how to create a table of values for a linear relation and then graph it. So we'll start with our equation y equals 2x minus 6. You have the option, if the x column is blank, to fill in with your own values, but I've just put the numbers 0, 1, 2, 3. You can also start in the negatives just to get a little bit of balance to the left and right of the y-axis. But let's start. So we're going to work on the first row when x is equal to 0. We're just going to go in our equation, and wherever we see the x, we're going to fill in the appropriate number. So in this scenario, we're going to have 2x, but instead of x, I'm going to put 0, minus 6. And then thinking about BEDMAS, multiplication comes first. 2 times 0 is 0. And then 0 subtract 6 is negative 6. Let's try the next one. 2, and then instead of x, I'll put 1, minus 6. 2 times 1 is 2. And then when we subtract 2 minus 6, we get negative 4. Again, 2 times 2, subtract 6. 2 times 2 is 4. And when I subtract 6, I get negative 2. And finally, 2 times 3, subtract 6. 2 times 3 is 6. When I subtract 6, I get 0. Now these represent coordinates. So 0, comma, negative 6 is our first coordinate. So when I plot it, I go to 0 on the x-axis, and then I go down to negative 6 on the y-axis. The next coordinate is 1, comma, negative 4. So I'll go to 1 on the x-axis and then down to negative 4. Then I have 2, comma, negative 2, 2 on the x-axis, negative 2 on the y, and finally 3, comma, 0. I go to 3 and then I don't move up and down. And then I can connect my points with a ruler and then arrows on both sides. Because I am going to graph one more line on here, I will label this y equals 2x minus 6. And then that's it. Let's go to the next one. We will ignore those first differences for now. Our next equation is y equals negative 1/2 x plus 3. First of all, I see that my slope is negative, so I do hope that my line will be facing downwards. I also see that the y-intercept is 3, so I can use those as a little check for myself when I do actually graph it. So negative 1/2, and then instead of x, I'm going to put negative 2. And then we can do the multiplication. And you can go to your calculator here and do negative 0.5 times negative 2 to get positive 1. Or you can actually just multiply the numbers, and I would put the negative 2 over 1. So when I multiply the tops, that would be positive 2. And when I multiply the bottoms, I get positive 2 again. 2 divided by 2 is 1. And then 1 plus 3 is 4. For the next one, negative 1/2 times 0 plus 3. Well, 0 times anything is 0. And then when I add on 3, I get 3. Negative 1/2 times positive 2 is negative 1. And when I add 3, I get 2. And finally, negative 1/2 times 4 is negative 2. And then when I add on the 3, I get 1. So I'm just replacing x with whatever I have written in the x column. Now notice here, I chose values starting in the negatives, but also they're not one after another. It's not like 1, 2, 3, 4. They're all even numbers. And the reason I've done that is because my denominator was a 2, so I chose to use multiples of 2. That way, I never had to deal with the fraction because once I did the multiplication, the fraction disappeared. If, however, let's say I had x equals 1, well then I'd have negative 1/2 times 1, which is negative 1/2, and then I'd have to add 3. So then I'd have fraction addition, and that's just too much work for just creating a table of values. So I chose numbers that were multiples of 2. All right, let's plot these points. We have negative 2 and 4. So I go to negative 2 on the x-axis, and then up to positive 4. Then I have 0, 3. So I go to 0. There's that y-intercept I was expecting, so that's good. 2, 2. And finally, 4, 1. And then we can connect our dots. Arrows at the ends, and I will label my line with its equation. And the line is going down as I hoped. Now, let's bring those first differences in to finish those tables before we go to the next two. Now, your first differences are found by subtracting consecutive y values, and you're always going to go from the bottom to the top, okay? So I'm going to go to my y values. I'm going to start at the bottom, and I'm going to pair up the y's. So 0 subtract -2. The double negative actually turns it into addition, so 0 plus 2 is 2. Then I go again. -2 subtract -4. Again, the double negative makes it -2 plus 4, which is also positive 2. And finally, -4 subtract -6 gives me 2 once again. Be very careful with your signs here, because if you're not careful with your positives and negatives, it can really mess up your first differences. Notice here, our first differences are the exact same. They're all 2. Let's see if that happens in our next scenario. So again, starting from the bottom, 1 subtract 2 is -1. All right. 2 subtract 3 is also -1. 3 subtract 4 is also -1. So our first differences were the same. Now, this should happen if you have a line. So when the first differences are equal, the relation is linear. So I can give you some random table of values that is completed, and I can ask you, is this linear or non-linear? And if you just do your first differences, bottom minus top, if all the numbers are the same, it's linear. If there's something that's different in there, it is non-linear. All right, let's try some more table of values. So our next equation is y equals -3x plus 1. I left the x column blank, so you have the freedom to choose whatever values you want. Now let's just say we'll mix it up. I'll start with the negatives. I'll do -1, 0, 1, and 2. So how about you pause the video here and do what we just did in the previous examples. Replace x with the appropriate number and then simplify it using your calculator or some mental math. Then come back to the video to check your work. All right, so we have -3 times -1, which is +3 plus 1 to get 4. Then -3 times 0 plus 1 is 0 plus 1, which is 1. Then -3 times 1 plus 1, -3 plus 1, which is -2. And finally, -3 times 2 is -6. And when we add the 1, we get -5. Let's plot the points. -1, 4, 0, 1, 1, -2, and 2, -5. Now, just a logic check. I wanted my y-intercept to be 1, and it is. I wanted my slope to go down. I wanted the line to go down because the slope was negative, and it is. So this is a good sign. And then I'll just label my graph. And then again, why don't you take a pause here and finish those first differences, see if they match. They should, but really be careful with the signs so that you don't make a silly mistake. All right, my bottom minus top, -5 minus -2 gives us -3. -2 minus 1 also gives us -3, and 1 minus 4 also gives us -3. It's this first one at the bottom that potentially could have given us some trouble. All right, last one with the fraction. So for the x values, to be smart and selective with our x values, I see that my denominator is a 3, so I want multiples of 3 in my x. So I'll start with a negative. -3, 0, 3, 6. I'm just adding 3 and I'm starting in the 3s to make sure it's a multiple. All right, so pause the video, Try this out on your own, then come back to check your work. All right, so we should have 2 over 3 times -3 subtract 4. When you multiply your fractions, you should end up with -2 subtract 4, which is -6. Then 2 over 3 times 0 is 0. Subtract 4 is -4. 2 over 3 times +3, subtract 4. The fractions, 2 over 3 times 3 is 6 over 3, which is 2. Subtract 4 is -2. And finally, 2 over 3 times 6 is 4. Subtract 4, which is 0. Let's go ahead and plot these points. So we have -3, -6 down here. If you haven't plotted your points yet, you might want to pause the video, try plotting them on your own, and then come back to check. 0, -4, 3, -2, and 6, 0. Connect your dots, label your line. And a logic check, we want the y-intercept to be -4, which it is on our graph, and we want the line to go upwards, which it is. Finally, let's do those first differences to make sure they're constant because this is linear. And because I know it's linear, I do expect them to be constant. If they're not, that would tell me I made a calculation mistake somewhere. 0 subtract -2 is 2. -2 subtract -4 becomes -2 plus 4, which again is +2. -4 subtract -6 gives us +2 again. So I know I'm on the right track because they're all constant. So that's it. When you're trying to graph using a table of values, pick your x values if they're not given to you already, and then plug those values into your equation that's given to you one by one, simplify it with your calculator or some mental math, and then plot your points. Remember, each row gives you the coordinate. The x on the left with the y on the right together create one point.